Hello, hello again. We are graphing a system of linear equations. Remember, linear, think line. So we're going to be graphing straight lines. And today's day 2 of it. So if you need help with day 1, go back and look at the day 1 video if you need a refresher. But we are going to start off strong with graphing systems day 2. So you see in my notes, it says the same steps as before. So we're going to follow those same 1, 2, 3 steps, but now our equations are going to be a little more complex. They're not going to be necessarily in y equals mx plus b or slope-intercept form to start. We're going to have to do some manipulation that we know how to do. So let's look at this. We have 2x minus 3y equals 9. Well, I'm going to do some work off to the side. And what I want to do is put this in slope-intercept form. So I'm trying to get y by itself. Well, if I subtract 2x from each side, I get negative 3y equals negative 2x plus 9. So all I did was subtract that 2x over. Now, I'm trying to get y alone, so I'm going to divide all pieces by negative 3. So those negative 3's cancel and I get y all by itself. Now we said that if you love your fraction, it'll love you back. Oh yeah, there you go. So my first piece is negative 2x divided by negative 3. A negative divided by a negative becomes positive 2 over 3x. And my second piece is positive 9 divided by negative 3. Well, a positive divided by a negative is going to give me that negative 3. Well, I know how to graph this. I'm going to start down at negative 3. I'm going to rise 2 and run 3. I need 2 dots to make a line. And then bam, that green line represents that equation. Well, now when I move on to equation 2, because remember system has 2 parts or 2 equations, I could do this one looking for my intercepts. X plus y equals 2. Oops, sorry about that. X plus y equals 2. Well, if I cover my y's, I get x equals 2. If I cover my x's, I get y equals 2. When I come over to my graph and I go to where x is 2, where y is 2, and I connect those with my blue line, there you go. I have myself a system of equations. This is just like before. I want to find my solution. Well, my solution is where they intersect, and that looks like 3, negative 1. To check it, I'm actually going to put it into equation 2. Equation 2 is a little nicer of an equation. It's a little simpler. So equation 2 is x plus y equals negative 2, or 3 plus negative 1 equals, that's positive 2, equals 2. Well, 3 plus 1 is the same thing as 3 minus 1. Does 2 equal 2? Yep. So my solution is 3, negative 1. Okay, so example 2. Let's start off by looking at 3x minus 4y equals negative 4. Well, just like before, I'm going to put this into slope-intercept form, or y equals mx plus b. That's the easiest way I can graph things. So if I want to move this equation into y equals mx plus b, I'm going to subtract 3x from both sides of my equal sign. So I get negative 4y equals negative 3x minus 4. Well, now if I divide all pieces by -4, I'm trying to get that y alone now. Those -4's cancel, and I get y equals, well, we said that if you love your fraction, it'll love you back. Well, -3 divided by -4 gives me a positive 3/4x. -4 divided by -4 gives me positive 1. So I come over to my graph. I begin at that B, or positive 1. I rise 3, and I run 4. Well, when I connect those with my line, there we go. That green line represents that equation. So now I'm going to do my next equation, which is -3x plus 2y equals -4. Well, I'm going to add 3x to both sides because I'm trying to get that y piece alone. My 3x's cancel, and I get 2y equals 3x minus 4. My last step is to divide by 2. Don't forget to love your fraction now. Well, those 2's cancel. Y equals positive 3/2x minus 2. I come down to my graph and I begin at my B, or -2. I rise 3, run 2. Rise 3, run 2. Ooh, I already see where they intersect. I already see it. And there we go. Well, I see that my points touch and my lines overlap at 4, 4. Well, to check that, because we always want to check, I'm going to plug it into, you could choose either one. They're both equally as complex. Let's just go with number 1. Why not? 3 times 4 minus 4 times 4 equals -4. Well, 3 times 4 is 12, minus 4 times 4 is 16, equals -4. Well, 12 minus 16 does in fact give me -4, and -4 equals -4. Check. We are all good to go. So these are about as complex as you'll see your systems problems. But now we're going to move into 2 special cases. Special case 1 is this one. I have these 2 equations, 3x minus 9y equals 18, and y equals 1/3 x minus 2. My question says, how many solutions does this system have? Well, right now, we've only seen systems that have one solution. But if I look at this and I say, I'm going to solve this using intercepts. Well, if I cover up my y's, I get 3x equals 18. If I divide both sides by 3, x equals 6. Meaning my x-intercept is going to be at 6, which is way over here. Now my y-intercept, if I cover my x's, I get -9, y equals 18. Divide both sides by -9, and I get that y equals -2. So I come down to -2. I do a dot. and I can connect those two dots with that fuchsia line. We're using fuchsia today. Well, for my second equation, it says y equals 1/3 x minus 2. Well, I can go ahead and graph this because my slope is 1/3 and my b, or my y-intercept, is -2. So come down to -2 and you do your dot. Now I rise 1 and run 3. If I can't go up to the right, I can always go down to the left. Well, uh-oh. When I go to graph this line and I put my blue line over my blue dots, what happens with these lines? They're the same line. If you look at that, they both begin at the same point, and they're the same line throughout the whole problem. This is a special case because if you have two equations that are in fact the same line, you have an infinite number of solutions. You have infinitely many solutions because I could pick any point on the entire line and it would meet the requirements for the other point. It would match the other line too. So this is special case 1. The same line has an infinite number of solutions. Well, let's take a look at special case number 2. Special case number 2 is this one. Y equals -2x plus 1. Well, if I graph that, my b is 1 and my m, or my slope, is -2. So I begin at +1 and I go down 2 over 1, down 2 over 1. Aha, there you go. Bam. That red line now is my graph. Sorry about that, guys. So I got my red line. Now my blue line is going to be this equation. My slope is -2 and my b is -3. Or I begin down here at -3, down 2 over 1, or I could go up 2 to the left 1. Now when I put that blue line over my blue points and I look at this, do my lines ever intersect? No, they don't. Let's look at my slope. Do those lines have the same slope? Yeah. So these two lines are decreasing at the exact same amount, and they'll actually never cross each other because their y-intercepts are different. So if you have parallel lines, with a different y-intercept, meaning they're not the same line, there's actually no solution to this system. They'll never cross, and my solution is where my lines cross. So this is special case number 2. And now you're going to move on to try some on your own. So flip your paper over, get going, and I'll see y'all in a few.